salvation hope that the 2020 we did not want to see is in the past. A very, very warm welcome to everybody who is logged in today from far and wide, from places where it's very, very cold to places where the weather is really, really nice and the sun and the beach is out here, as in Dubai. I would welcome you all. Please do familiarize yourself with the controls somewhere towards the bottom when you take your mouse or your cursor or on your touch screen. You would be able to see a question and answer icon, which you can use to ask specific questions through the course of the presentation. You would also see a chat window. I know that many of you have been using it. Many of you are actually very, very familiar with this medium. This is the new world we are all in. There are a few people who wanted to know if there are any PDH or CPD points for this, and unfortunately there are none. I realized that the CPD as the organization in the UK or others were charging a bit of money. So in the era that we are in. So let me begin. This webinar, like many other webinars, is recorded. We will be sharing a copy of the recording with everybody who has logged in or registered as well. As mentioned, please use the question and answer option to ask specific questions. And the questions in the chat window may not be answered, but would be looked up. On certain slides, you're going to see a blinking marker for a poll. You would be able to see, and I would urge you to answer the poll questions just to help us get a better idea. Many of you may already know me. My name is Abhishek Chhabra. I have a very broad spectrum of experience across many businesses, and a lot of it, almost last 2 decades, have all been around compliance or conformity assessment. I spend a fair amount of time trying to increase awareness as well as contribute. You can see on your screen some of the contributions that I have been involved in. I also have a website/blog and a large group on LinkedIn called Gurus of Testing Inspection Certification, which brings together people from all walks of compliance and conformity industry. Also behind the screens is my colleague, Sujana, who's going to support me a little later during the program. She's got hundreds of tests as an experience and was a faculty before that. Also, Ruben, who is behind the screens and is supporting us on the logistics of this program. I see many, many new faces, people who might not know us. So let me quickly tell you, I represent a company called Thomas Bell-Wright International Consultants. We've been here in the region for over 25 years and started off as a curtain wall testing laboratory. And over the years, over the last decade or more, we got into testing for fire. So we started off with a 3x3 furnace to do fire resistance tests and some reaction to fire tests. And over the last 6 odd years, we have been expanding heavily on supporting the industry as well as governments in the region to get a better understanding of both passive fire protection as well as compliance and conformity assessments. We have 4 furnaces, 2 large-scale fire propagation test rigs, one for the American standards ASTM E2307 and NFPA 285, as well as the BS 8414 test. We also have a slew of smaller reaction to fire tests as per the European as well as the American standards. So as I welcome everybody to today's program, we have the new decade that has started. We continue with our awareness program, which is aimed at sensitizing people across the industry about pacifier protection, as well as conformity assessment. And today I have chosen a subject which is, in my opinion, quite a complex subject in many ways. I'm trying to talk about the European norms as well as the American norms and quite a few things today. So I would start with a small disclaimer that please, if there is any error or omission through the course of the discussion and the session today, please do forgive me. And I'm going to start with talking about perimeter fire barriers, as the industry around us has had a very, very increased sensitization to building envelope, cladding fires. This is a subject that often pops up. And I'm going to begin with talking about the fact that, when we are sitting in our offices or homes, we sometimes don't quite realize the complexity of the systems as well as the materials that are used to bring about very basic properties that we often take for granted. The building enclosure or weather tightness or just the building comfort is one such thing where very often we forget that what are the designs, materials, components that have been brought together to ensure a very large number of properties are delivered by the building envelope. So today we talk about one such material, which is the perimeter fire barrier. The perimeter fire barrier is probably a relatively small looking material for a lot of people who may not even know. But its functionality is very, very critical to fire safety. What you see on the left as an image on your screen is a gap which remains from the slab edge to the building envelope or the curtain wall or the cladding system. And this slab edge is filled in with several types of materials with more than one functionality, but one such functionality which is very important for fire safety is the perimeter fire stop. The definition that you see on your screen is from the American standard, the ASTM E2307, which defines the perimeter joint and perimeter joint protection. And we today will be talking about fire resistance and compartmentalization as a characteristic which needs to be brought about by this material, which could be one material or a combination of materials. So as we begin our journey, I would like to open a small poll for everybody in the audience. I hope you can see this poll on your screen. This is really going to be helpful for me as I talk further today through the course of my slides, as the people who've logged in come from many different professions, many different educational backgrounds, as well as many different focus areas. And the subject that I am planning to cover is or can be a bit too technical. So it would really, really be helpful for me to know where the audience is in terms of understanding and to what depth should I go and what kind of examples I should be taking through the course of today's session. A few more people who are left to vote. I would encourage you to finish off clicking the buttons. It's a very, very simple poll to understand how many of you would understand drawings or renderings, or how many of you are the kind of people who would actually be at the construction site and be very, very familiar with some of the pictures on the top and bottom right on your screen. So thanks everybody for clicking in and voting in. Let me move forward to talk about a concept which is sometimes not very, very well understood is the fact that building envelopes, like several other complex systems, are often made using materials coming from far and wide, materials which are often manufactured or batch manufactured in factories, sometimes close by, sometimes far, far away. And many of these materials are able to demonstrate repeatability in how they are, how they perform, and the kind of materials that these are in terms of their capability. And often these materials are used to design one of several types of systems. As well as this, the assembly and the installation is probably done by some other people. So it is often missed out how the connection between all these three comes together. A lot of you have replied back in the poll that you are familiar, very well familiar with curtain wall systems and designs. A good percentage of the attendees are probably very well aware that when a curtain wall system is brought together, it is sometimes few dozen or hundreds of different drawings in order to bring about the final building envelope. And hence, we must understand that the material property and the resultant system property can be very, very different. The same set of materials could give several different combinations of resultant property based on how they are brought together, based on how they are installed, and also very, very important, as people are realizing now, on how they are maintained. So with this as a background and a kind of an understanding between materials and systems, let me jump to fire resistance or compartmentalization as a concept. A short video that is running on your screen, I would encourage all of you to try and imagine, wherever you are situated, wherever you are sitting. You could probably be in your office. Imagine if there was a fire that happens right here, or in the video that you see running around, how the fire would go around, and whether the fire as well as the smoke can be contained within the area where the fire has broken out. And the reason I want to show you this video is for you to think and try and connect and just imagine around you that how the compartment might actually be getting into place. And the reason why I wanted you all to visualize all of this is because the product or the system or the assembly that we aim to test in order to validate the performance of fire resistance or compartmentalization is often not a very straightforward system. Some of the videos that you see are kind of renderings using SketchUp, but in real life, all of you are aware that ensuring that a system is going to come out, perform, and live all through its life can get a bit too complex. So with this as a background and an understanding, let's jump to the two key European standards. These are the standards which are used for the evaluation of the perimeter fire barrier as well. And as I'm going to talk about these two test methods, I will generally and roughly cover up what all they cover, probably not in great detail, but the aim, as I said, is to talk about the perimeter fire barrier. There are two different standards. There is EN 1364-3 and -4. These two different standards are for the full configuration or the part configuration of what can be tested. And as many of you are familiar with the fact that curtain wall systems or building envelope system have several materials and elements, and an extremely large number of combinations that can be used to bring about the properties. So let's begin with a general understanding before we get into testing. What you see on the screen is from the standard. The solid line that you see represents how a full configuration will test a part of the curtain wall or the cladding system, whereas the dotted line gives you an idea of how a part of the configuration of the test is done. Here is another image of another type of system that can be tested. You would notice transoms and mullions in this, and you would notice, and you can very clearly imagine that the potential combinations are an extremely large set. So as I would not be delving into details, I would just be giving an overview. The -3 is for a type of system which is defined as a type B system. A type B system is such which has a fully fire resistant curtain walling system, which means both the spandrel, the glazing and everything is fire rated. Such a system would define a building envelope which will ensure that the fire, if breaking inside a compartment, will be contained within the compartment as well as within the flow. And it will also ensure that if there is a fire that breaks out in the adjacent building or outside the area where the curtain wall system exists, and because the complete curtain walling system is fire resistant, the whole system will be fire rated, and hence the test method allows and gives a methodology of how it can be tested for an internal exposure as well as an external exposure. Point to be noted is that these two standards, the 1364-3 and -4, point to two other test methods, which is 1363-1 and -2, which define the general methodology of how fire resistance of various construction elements, as well as alternative and additional procedures, is to be conducted. And hence, this test method further or cross-references to another standard. While the test can be used to evaluate the complete assembly, the complete system with all the components, it should be noted that the test method is also used to evaluate vertical linear gap seals. The coverage of the standard should be noted that it is for a non-load bearing curtain walling system, and it creates a predetermined, agreed to, and verified by everybody who has participated in evolution of the standard of what is the type of exposure or the fire exposure that the system will have to withstand, which is representative of, as mentioned, the internal and the external exposure needs to be conducted separately as two different tests. It provides a conformity assessment for a curtain wall assembly, which is only type B. Many facade systems, curtain wall systems, have many faces and several different renderings or several different ways that the facade looks out. So this standard is for a faceted curtain wall system and provides several ways on how in a single test many different design elements can be tested. The test method does not provide any compliance or conformity assessment for a double skin facade or an overcladding system or ventilated facades on the external walls. It does not evaluate any reaction to fire behavior of the curtain walling system. Moving to the part 4 standard, which is the EN 1364-4. This is used to evaluate a system which is called a type A system. And a type A system is such that the glazing may not be fire rated, but the fire resistance system outside the spandrel panel is fire rated, which means only the spandrel area, which would also have the perimeter fire barrier and all the design elements that ensure that the fire does not break out from one floor to the adjacent floor above or below, is validated through this test, which means that this test is applicable in those scenarios where it does not require that the fire can intrude into the building from an adjacent or an outside building into the building. This test method focuses very, very specifically on the design elements, materials, components, and systems arrived at for the spandrel area of the curtain wall system. And as mentioned and clarified, there are several components, design elements, like the upstand and the downstand or the combination, fixing systems, framing systems, which are used to ensure that the system hence deployed will be able to help contain the fire within the compartment. The beauty of curtain wall systems, the way they have evolved in the last 2 to 3 decades, has an extremely wide variety and combination of different materials, design methodologies, components, many of which are repeatedly used or designed to be repeatedly used in several different configurations. And this possibility of a repetition of designed elements is what is behind development of such test methods, because these test methods help not only evaluate materials as separate, designed systems as separate, as well as the complete designed assembly as one option. Hence, unlike some other standards, these European standards are able to give a very wide variety of results and have a very wide spread of usage. As mentioned, these results form the basis of classification of a curtain walling system, which is type A. But I would also like to add that the type B result can also be used to determine the fire resistance of parts of curtain walling system, and hence the other test described earlier can also be used for evaluating the components. It does not test a non-load bearing curtain walling system, and the same as part 3, that it is a predetermined test exposure. A single test can cover conditions of internal and external exposure, because in this case, we are evaluating the behavior of the system, which is only in the spandrel area. It provides for the spandrel panel, perimeter seal, fixing of the framing system, and also a combination of all. Here, as mentioned, This standard can be used to evaluate materials, designed elements which can be used repeatably in different types of systems, as well as systems or the complete system as well. And hence, these test methods have a lot of functionality. This test method does not provide any evaluation for a double skin facade or overcladding system or ventilated facade on external walls. Just like part 3, this test method does not evaluate any reaction to fire behavior of the curtain wall system. Now, a lot of you are familiar with the fact that the perimeter fire barriers and a lot of materials and components need to provide for cycling and building movement. I would like to add that the movement and cycling can be undertaken before the tests are conducted, and the European Technical Approval Guideline 026-3 defines how this is done. How the tests are performed, again, these is what takes almost the largest part of managing and planning for a test like this. And this is because these two European test methods provide an extremely wide array of options as well as combinations that can be evaluated. On the screen, you see one of probably several hundred different combinations of tests that can be undertaken. But just to add on a small list, which is not exhaustive at all, about some of the several parameters, like the classification of glass, or what are the kind of framing systems that are being used to design and build the curtain wall system, the depth and width of transoms and mullions, and so many relationships that thus evolved when we talk of different geometries, how these members combine, what is the type of timber that may be used, what are the type of coatings that may be used, and so on and so forth. In my opinion, tests like these are very, very exhaustive and often not used to the extent that they can be or should be used. On the screen that you see are two images of our horizontal and vertical furnace. And the test method defines several ways in which these two furnaces can be used to build a mock-up. And more often than not, it is this part of the project which would often take an extremely large amount of time. Some of you who are very familiar with this test know that slabs need to be cast, which have a curing period. And because there is so much that can be drawn out of the test, that people would like to maximize the expenditure incurred and hence try to position in and push through lots of different types of configurations. Such a test is also very often used and can be used in a place like UAE, where time is of prime importance, and the designed end result may not always be assessed for conformity by using certification and listing or the standard approvals, which are used more as a trade regulated mechanism between countries. And hence we see, and we are seeing more and more systems where the consultants, the subcontractors who do not want to take on liabilities which are now adding on to their portfolios because of the fires coming in, would opt for a representative test for a given project. I'm also reproducing a table, one of several tables which are there in the standards. I know the webinar is getting recorded and attendees can look through back at this table to understand combinations, but this is not at all exhaustive, and we can go in detail in one-to-one when required. The test conducted, like most of the fire tests, gets over fairly quickly as against the time and the effort spent to plan and prepare for the test. On the screen, you can see some of the images of a curtain wall test that we have conducted, and the result is fairly quick and short. Pass or fail, or a classification can be given, but often for the European standard and for the European tests, the results can be used to draw out a very wide variety of influence. Moving on, as my friends in the UK would say, across the pond to the United States, we would look at another test method, which is the ASTM E2307. And unlike the European version, this test method is very, very focused on just the perimeter fire barrier and testing just the perimeter fire barrier. So I'm going to read out a bit of what is the scope. The test method measures the performance of the perimeter fire barrier and its ability to seal to prevent the fire spread. Prevent the fire spread and during the deflection and deformation of the exterior wall assembly and the floor assembly during the fire test, while resisting fire exposure from the interior compartment fire, as well as the plume which gets emitted from the external window opening. I must add something which I probably should have detailed at the beginning. The European test method is conducted in a standard fire resistance furnace, which is a vertical or a horizontal furnace as shown in some of the slides earlier. And these furnaces are used for fire resistance tests for several other containment elements like doors, partition walls, fire stopping, etc., etc. Whereas the American test method uses a very unique test apparatus, also known as the ISMA or the intermediate scale multi-story test apparatus, which is used to evaluate the fire propagation behavior of cladding as well. Even though the fire exposure in the first 30 minutes of the test is similar to that of the NFPA 285 test, which is also conducted on the same rig, the later part of the test follows the time temperature curve of that of ASTM E119, which is again an American fire resistance test. And hence the image that you see on the bottom right, where you can see the mock-up, which is to be tested, as well as the intermediate scale multi-story test apparatus, is the bottom compartment, which replicates a fully developed fire that would exist and needs to be contained. In this test, the cycling conditions are limited to only what is tested. The cycling is more clearly and openly defined as compared to the approach of the European approval and the methodology by which you would demonstrate the behavior of cycling before the test. The assembly behavior is what is evaluated. In this test, measurements are done only for the specific test conditions, and this test is defined as it should not be used as the only selection criteria for a perimeter fire barrier. The test does not, and is very clear to define that it does not quantify the contribution to the fire hazard by smoke, toxic gases, or it does not quantify how much smoke is produced. It does not quantify the rate of flame spread or fire propagation or the durability of the test specimen. It does not cover the effects of a load on the movement, cycling, or it does not cover rotational, vertical, or horizontal shear capabilities. Here you can see on your screen lots of things, lots of movement, On the bottom left, you see almost like a fast forward video of how the test rig is mocked up and various positions where thermocouples are put in place. At the top left or main part of the screen, you would see what we call as the time temperature curve. The red pointer shows how, as per time, the temperature which is inside the furnace moves on and is increasing. And as you would notice, this test method is very, very different in its approach to how the test is conducted to evaluate the behavior of the perimeter fire barrier. The external plume, which attacks the spandrel area, as well as the bottom room where the ASTM E119 related environment is created. The conditions of compliance are several. If movement cycling is done, its result is reported. The T rating and the F rating, as well as this test method, unlike the European tests, can allow and do allow for the perimeter fire barrier to demonstrate its performance under the load condition of the perimeter fire barrier. The comparison of the two tests, which is very, very often asked, is unfortunately not a straight, simple answer. As you would have understood slightly, and I went to much greater detail in describing the European test as compared to the 2307, which I had undertaken a webinar last year as well. Apart from the fact, which is very clear and evident, that the American standard does look at how a loaded perimeter fire barrier would behave, unlike the European equivalent. The approach of the two tests is very, very different, both from understanding of how conformity assessment or compliance is realized as well as understood. And moving on, I would like to talk about the subject which is critical to understand and as a background of understanding the two tests, which is how conformity assessment or compliance is to be perceived and understood. And before I get into it, I would like to touch up upon a slide which I always use, is to sensitize the audience to understand that how codes of practice and methods and guides are interlinked. Many of you are very familiar with the building codes or the codes of practice like the NFPA 101 or ADB in the UK or the UAE Fire and Life Safety Code and several other codes of practice, which almost set the minimum criteria based on the recommended good practice, which is currently undertaken. But test methods are the documents or the methods which really evaluate from a repeatability point of view that how a performance will be evaluated. So if there is a test method which is evaluating fire resistance, it will evaluate repeatably in the exact same criteria, in the exact same methodology, irrespective of different materials or systems being put to it. Guides like the ISO 17025 guide for laboratories are documents which give a very, very less prescriptive kind of advice and defines how generally things should be undertaken. So this is kind of a background before we talk about compliance and conformity assessment. And I want to just very quickly show that while many of us may want that compartmentalization should be maintained and fire resistance should be maintained thoroughly and in almost like an airtight way, and it would be just magical if the perimeter fire barrier was something like this. But this is something which is not practical, and there are lots of gaps why the perimeter fire barriers are not like this in buildings. And a lot of that has got to do with the fact that construction has changed. The goals of developers and contractors are different. A very nice video which I found on SketchUp. This is the building designed by someone of, I think, the Avengers, if I'm not wrong, but not very different are the top 6 buildings on the CTBUH skyscraper directory. And you would notice that quite complex looking building facades need to be realized. And among scores and scores of desires of how they should perform for weather, fire, and fire resistance is one of several such properties that needs to be ensured. So how do we really ensure that for such complex systems and designs, fire safety is instilled? And this starts with the fire properties of materials, which means we need to have a very high degree of confidence in the mechanism used for assessing and ensuring that any material that is used to design and implement a desired system completes its promise of how it will behave on all the grounds of physical, mechanical, as well as fire properties. And once this promise is fulfilled, it is on the basis of this promise that the second promise will live up to. And this promise is of those experienced, very, very experienced designers, and sometimes inexperienced designers as well, who would bring together the different materials which would add up to provide the end result and the properties. And this is where validation of mock-ups is very, very critical, because it is important not only to validate the design ideology, but to verify that the materials which were so-called promised to live up to their name, are they really able to deliver what is designed? And then comes another challenge of ensuring that what has been designed, what has been specified, is exactly what reaches to the final construction site. And hence, this verification becomes extremely important. And as very, very much in the news nowadays across geographies, is that the installation needs to be verified, and maintenance is also very, very critical. I talk about certification and listing in almost all my workshops, and this is one of the most evolved methodology of assessing the conformity of different materials, where through a process of certification and listing, the third-party independent body enables and brings about the trust between the buyer and the seller by bringing in several measures and methods to ensure that if a seller going to a buyer claiming that his product or material will behave in a given way, there is an online verifiable report which has assessed such a material to great detail by conducting tests as well as audits. And it is not just from the certification directory or Thomas Bell-Wright. There are loads and loads of third-party certification bodies who employ very easy to use verification mechanisms, certification and listing numbers, traceability that is visible on the material at the site. And it is very quick and easy for you to look up the conformity assessment marks, numbers, and verify that yes, the material which is being used to arrive at an evolved design will live up to what it is promising to. And this is where we talk about conformity mechanisms for a system and how the complete system needs to live up to its promise. And this is validated through the system tests, which are done. A lot of you are familiar with these design validation tests. On the screen that you see a few videos kind of running, some of which are talking about how these design validation tests are conducted. And all these tests, they just end up to validate that the materials that were procured, which could have been perfectly good materials, they are able to be installed in the way that the end result wants them to be. And mind you, some of the failures that you see on your screen, the fire test, which almost the panels exploded off in the NFPA 285 test. We were very sad, but it is a reality that the same set of materials, exactly the same set of materials, were able to comply to the same test just by redesigning the system and much better installation. And hence, it brings me to the last kind of section of today's session. And I want to open a very small, quick poll. I want people who've logged in and are listening to just quickly tap in the replies and say yes or no to this poll that I have opened. This poll will, help me understand that as listeners, all of the people who are logged in and have been here online for the last 40-50 minutes, how exactly probably you can benefit from what we talked about today. Because the only two ways in which responsibility can be quantified to prevent liabilities coming on your organizations are the specifications and the contract. These are two sets of documents which are almost in your hand. It is in your control. I see a good percentage of people in the audience are responsible for either implementing or writing specifications or contracts. And all of you must know that it is the specification document, which is probably the governing document. It is the place where conformity is assessed. It is the document which defines how conformity should be proven, should be assessed. So I urge everybody who really feels that any part of their mind or heart that yes, fire safety is important, should pay a little more attention to the specification document and how quality assurance is validated and checked on the site. Many of you would have noticed and seen that when the times are tough, like 2020 and now, you will notice that across the supply chain of the construction industry, right from developers, contractors, consultants, project management companies, also in the light of what has been happening around the world when it comes to awareness about conformity and conformity assessment, or lacks in conformity assessment, which have led to big catastrophes, are leading to learnings among people. So I'm going to conclude by a few points which will help listeners understand that how conformity assessment should be clearly defined in specifications as well as contracts. So what you see on the screen is not only telling or kind of guiding that the conformity assessment mechanisms should be clearly defined in specifications. The responsibility should be defined in specification, not just for delivering documentation, but also submitting proof in the correct order and in the correct way, as well as there has to be a linkage with the commercial contract. because until or unless there is a commercial implication to conformity and conformity assessment, the importance, unfortunately, is very, very low. That is the last slide. I'm going to take for a small break for a few seconds, and I'm going to go through the questions and answers. And please feel free to add in more questions, and I'm going to reply to some of these questions one by one. I hope that the session today was interesting for you. So let me start with the first question regarding cavity barriers. And I hope the question related that I was able to give a little more clarity about cavity barriers. The question about if a high-rise building has combustible exterior cladding and the landlord prefers to change this, what are the elements that are required to be changed? I'm going to reach back to you, sir, in a one-to-one call. Today, I will focus more on the perimeter fire barrier. But yes, this is a question that calls for a very detailed answer. I'm going to send you an email for this. Another question by, it's not exactly a question. I mean, Chris Mort is explaining what all has been done and what all SideRise has been doing. Good to know. Question: can TBW confirm if they have ever conducted EN 1364-3-4? Yes, we have done these tests in the past. Are your furnaces a 3D cube that it is can test horizontal and vertical at the same time? Our horizontal furnace can undertake these tests. Yes. I am being corrected that, sorry, you are fundamentally incorrect about loading. EN and ASTM impose loading on the full assembly. We would love to talk about it. There's another question regarding if any British standards apply within the Middle East region. I would like to answer that the UAE Fire and Life Safety Code gives several options for conformity assessment in terms of the standards. So they point to British standards, European standards, as well as American standards for most of the materials and components. So within the Middle East region, the most common countries where British standards could be applicable are UAE, to an extent Oman and Qatar, but Saudi Arabia is completely on American standards because they have adopted the International Building Code of the United States. And in 2018, the Saudi Building Code has been published, which points only to American standards. And Kuwait as well follows mostly American standards. The last but one question, any others? There is an anonymous question from an anonymous attendee that do you know if there are any changes planned in relation to the standard tests? That is, are there any known changes in the pipeline for the standards to which you discussed? I am sorry, I don't know an answer. I will have to trail back to the EN standards and the ASTM standard committee meeting records to find out, but I must say I don't have an answer to this question. So that brings me to some of the open questions. We have a few minutes, so let me jump into the chat. There is a question that do we have a accredited certification service for 1364-3 and -4? No, sir, this is not available from our side at this point of time, but we will soon be coming out with a certification program to cover perimeter fire barriers, as well as other components that get covered in 1364-3 and -4. Good stuff to see a good amount of marketing and business development happening on the chat window. That's fantastic. Whatever results in a good year and a good decade is okay with us. How is a perimeter fire barrier correlated with the aluminum composite panels? The perimeter fire barrier is a system/material which ensures that the fire does not move from one floor to the other floor. The aluminum composite panel is the fascia material on the outside, and they are two separate materials/elements, but the building envelope as a complete system, which would often come under the purview of a facade subcontractor and a consultant. They all need to factor in everything together. Any other questions so that we can close the session in the time that I have promised? Let me scroll the chat to see if there is anything. Thank you, Chris, for your offering. I couldn't have called you back. Again, there is no CPD for this session. I'll take this question as the last question. How effective is cavity barrier with reference to the response time is too short? Cavity barrier and the perimeter fire barrier, if nobody else corrects me, is separate. And I think I will have to schedule a call with you, sir, and we will speak soon and talk about some of the questions that you have been asking on the Q&A and the chat. So as of now, I'm going to close this session. Any last remarks? Thank you very, very much for the day. And yes, the video recording which is being done will be sent to all the attendees. Thank you very, very much to everybody. And as I said, please do pardon any errors and omissions. The aim of this webinar is to connect with all the good friends, well-wishers, sending wonderful wishes of the new year and the new decade, as well as increase the awareness regarding conformity assessment, as well as the tests and routes to fire safety that are available here with us. Thank you very, very much, everybody, and wishing you all very, very well.